So here we go, Calculus 2.3 with a thing called trig limits. So I can just imagine your joy because trig is just super fun, limits are super fun, so I mean you put them together and that's just unbearable fun. So the first question was historically a controversial question. We've been doing limits as x approach numbers, more so than limits as x approach to infinity. When we have limits as x approaches numbers, your first go-to move has always been just try to plug the number in, see what happens. On this, if you try to plug in, you get on top the sign of 0, which from our trig memorization days is 0, divided by 0. And 0 over 0 problems have always been historically controversial. You could argue for all different sorts of things. You could argue for 0, you could argue for impossible, you could argue for 1, and we saw in the lesson the other day, a lot of times the answers were actually like 3 or 7 or whatever. So sine of 0 over 0 is controversial. So I'll sit down for just a second and look at the book. I'm looking at 84. So they take a little bit of a guided history. In the end, you're just going to need to know the bottom line to survive the homework. But a little bit of history of just how you could try to do this. They went back to the ideas that we used in the first day when we learned about limits from 2.1. They made a graph to just look to see where did the graph look like it's headed. So on page 84, the very first graph they made, it's headed up to 1. It looks like if you have an x of 0 lined up with the y-axis, it looks like it's headed sort of this mysterious mountain. There's like baby mountain, baby mountain, baby mountains, and then this mysterious mountain peaks at 1, looks like. And then they did another thing we did the first day on limits, is just start making a table and pick some stuff that's close to 0. They used 0.1 and they got a 0.99, and then they used 0.01 and got a 9999, and they used an 001 and got a 9999969. And it became fairly clear that answer probably should be 1. But the math community likes to prove things. So people set out to try to figure out if they could prove a way that this could be true. And there's a thing that they used called the sandwich theorem. And the gist of this idea is somebody found a graph that would always be above the graph of this. And they found another graph that would be always below the graph of this. And the graphs that they found, there's a picture on page 85. These aren't the actual graphs, but it sort of hits you with the idea. On page 85, there's a red graph that's always above a blue. There's another red graph that's always below a blue. And at a certain spot, they basically pinch or sandwich in such a way that the two graphs kind of like almost touch each other, so you know where the blue graph would have to go. Now, this is the blue graph in the discussion we're having. It's always between two others, and those two others happen to pinch or sandwich, indeed at a height of 1. And then the math community was happy because this problem just became possible. The sine of 0 over 0, by rule, is just 1. Any problem in this homework that has sine of 0 over 0 based things, it's operating off of that sort of an assumption. If we did this upside down, the sine of 0 over 0 is 1. If I do the problem upside down and have 0 over the sine of 0, that is also going to be 1. Because if the problem flips, the answer just flips, and flipping 1 stays 1. I'm going to take a small detour over here. If I go to do this question, this answer you might expect might be 1, or you might be suspicious. The answer is not 1. And then if I tell you the answer is not 1, I'm guessing you could maybe guess what the answer would be, or maybe not. But once I tell you, you'll think, oh yeah, well, I could have guessed that. This answer is going to be 3/4. If there's coefficients involved, it's still the sine of 0 over 0 in its heart. It's still trying to follow this like sandwich theorem, you know, by rule it's 1 now kind of thing. But if there's coefficients involved, just make a fraction out of the coefficients. So that's trig limit rule number 1. Sine of 0 over 0 is 1. Just know it, just take it by faith that the math people figured that out for you in the book. But if coefficients work in, make a fraction out of the coefficients. This I can explain based on the foundation of this. Let me do this one. Tan, you probably remember from trig, is the same as sine over cosine. So instead of having a tan question, I can just put sine over cosine. That's a fair trade. There is an x on the bottom. If we try to do the limit as x approaches 0, this cosine of 0 is a new thing relative to where we came in. The cosine of 0 from your trig memorizing days is 1. And sine of 0 over 0 from a minute ago was also 1. You won't ever have to work through that in-between step again, but it justifies it in a simpler way than what the sandwich theorem was, to prove the other one. I could prove this one to you just with trig. Tan of 0 over 0, by rule, is going to be 1. If I put it upside down and do 0 over tan of 0, 1. If I take a step over here and I mix in coefficients, you'd probably guess this one right, or maybe I'd get you. If people were live here in the room, usually someone will yell 6/8, and then I could say, gotcha, 3/4 is best answer. We're still reducing fractions, but 6/8 reduced to 3/4. So again, to recap, sine of 0 over 0 is 1. Tan of 0 over 0 is 1. If they mix in coefficients, just make fractions out of those. That's not too bad simple. Don't be suspicious because I said so far. It's not going to really get that bad, I don't think. If we do cosine of 0 over 0, always first go with the go-to move. Try to plug the number in. Okay, so we only resorted to tricks because the sine of 0 over 0, it's a 0 over 0 argumentative problem. I didn't mention the chart right away on this. I probably should have. If we try to plug the 0 into this one, tan of 0 is 0. 0 over 0, that was an argument problem. We had to settle the argument. But if you plug 0 into these, the cosine of 0 is 1. So if we try to plug in, we get 0 on top of 1. There's no argument there. That's just 0. We could have done that problem 2 days ago. That would have been a fair problem. This wouldn't have been without the sandwich theorem, but this would have been. 0 plugged into the top is 0. 0 on the bottom is 1. It just works. This, if we try to plug in upside down style, cosine of 0 is a 1 on top. Plug in 0, we get a 0 on the bottom. 1 dividing 0 is controversial. So now we're back to notes from limits involving infinity from 2-2. Limits involving infinity from 2-2, the ruling that day was, if we try to plug in a number and we get something over 0, it's potentially an infinity answer. But to do an infinity answer, we have to be able to decide on what the sign would be. Okay. This is a positive 1 top. But this, we don't really know if we're a little more or a little less than 0. That was where I put the note up, beware the two-sided limit. This is a two-sided limit. Beware the two-sided limit. Frequently, those do not work out. And this one is one of those. This does not have an answer. If I wanted to create a similar problem that does have an answer, I could have squared this. If I squared this, I'm sure the bottom's positive as well as the top. Now it would be positive infinity. Or I could have said here with a plus that we're a little more than 0. Then I'm sure the bottom's positive. That's positive infinity. I could have done a little minus to make one-sided limits. Then I'm sure that's a little bit negative. Then it would have been negative infinity. If I get a number over 0, I can still get infinity answers, but I have to be able to decide on the sign. This one, as written, no answer because the two-sided limit kind of an issue. Speaking of limits involving infinity, so here's some sort of special cases on this. I actually already did, no, I made a mistake on that one. Limits involving infinity. This comes down to, again, is the top bigger? Is the bottom bigger, or did they tie? Okay, the limits involving infinity, when we had x approaching infinity, when the bottom had the higher degree, that was 0. When they tied, we made fractions. When the top had the bigger degree, we went with infinity and had a sign decision to make. For this, the trig changes this a little bit. If you do the sine of anything, you may or may not remember the maximum you can ever get out of sine is 1. Sine can't go above 1, either because sine is based on the opposite over the hypotenuse, where the hypotenuse has to be the biggest of a triangle, so that's got to stay largely under 1. Or maybe you remember graphing sine from trig. The sine graph looked like that. It never got bigger than 1. It never got less than negative 1. Okay, but sine's pretty small. Sine is somewhere between negative 1 and 1. No matter what angle you give it, it stays in that range from negative 1 to 1. And if you divide a number of that size by infinity, that's like my analogy yesterday about take a cookie to China and share it with everybody you meet. You get no cookie on that deal. This is going to be 0. You're having a tiny number divide by a giant number, that's 0. If you want to obey yesterday's rules, the bottom is clearly far bigger than the top. The bottom is clearly far bigger than the top. That's going to be a 0 answer. If I go upside down, it changes some of the logic. Now I've got a number on top that's humongous, and I've got a number on the bottom that's somewhere between negative 1 and 1. We're dividing a huge number by a tiny number. That's huge in size. That is absolutely infinite in size. But our issue, anytime we try to say infinity for an answer, is we have to have certainty of what sign it would be. And since the bottom can roam anywhere from negative 1 to 1, we really don't know what the sign is of the bottom. There's no way to resolve that, so there's no answer to that one. If I play that game with cosine, you're going to see essentially the same kind of thing happen. Cosine is also stuck between negative 1 and 1, because cosine is the adjacent over the hypotenuse. Hypotenuse has to be biggest, so there's boundaries to that. Graphing cosine looked like that. Again, bounded in between positive and negative 1s. So if we do the cosine of anything here, this bottom is tiny, but with some sign uncertainty. Negative 1 to positive 1 is our zone. So we know it's tiny, but we don't know the sign. Top is humongous. Top being humongous, because we're putting infinity in, makes us want to kind of say infinity, but since you can't decide on the sign, you can't do that one either. This one we can do. This time, when we do the cosine of any angle, it stays between negative 1 and 1. This is something tiny. And when we divide something tiny by an infinite number, our cookie just went to China again, and we got no cookie on the deal. I didn't do any tan questions like this because you can't, because tan is a mystery. Okay, why we can think through these a little bit is that sine and cosine have boundaries, that they stay between negative 1 and 1. Tan was a graph that looked like this. It's just boundless. It goes gigantically big, it goes gigantically negative, it stays in the middle, it's everywhere. So we can't ever do an analysis of tans with this kind of a thing. Last one, if I mix in, or the book mixes in, a cosecant, what you'd want to do is exchange cosecant for its fraction-y friend. Cosecant is fraction-y friends with sine. So sine on the bottom, x on the top, this would be a fair rewrite of this. And now we're doing 0 over sine of 0. That's the question we came in on with the sandwich theorem. It's just the upside down version of what we did. That would be a 1. As a what if this had a 10 there, this would continue to have a 10 with the x. Now the answer is 10. If this had an 11 there, this would continue to have an 11 there, and it would be 10 11ths. I think they mixed some of that stuff in with cosecants and secants and cotangents, just turn them into sine, cosine tangents for comfort level. That's trig limits in a nutshell. The homework based off of this is page 89. No, yes, page 89. We're skipping the 3s and we're working to 38, and then message me if you run into anything that you need to get interactive about it.